Hi dear students, welcome to the question discussion session, the continuation from moving charges and magnetism. In the last sessions we have discussed till question number 28 and today we are going to discuss about from question number 29 onwards till 45. So that is our last session from this chapter. So let's move question number 29. Deflection in galvanometer falls from 50 divisions to 20 when 12 ohm shunt is connected. The galvanometer resistance is, what is given? Deflection in the galvanometer is falls from a particular value. What is the value? From 50 to 20. And what should be the shunt resistance to be connected in parallel? So there is one term which is something called figure of merit. Okay, figure of merit of a galvanometer. Okay, what is actually the figure of merit? Figure of merit is the minimum deviation, because in a scale, if you have taken, you know each deviation is called a deflections. Okay, so here main scale reading from 50 to 20 it is falling, means 50 is the highest value, 20 is the minimum value. With only galvanometer I can measure a minimum value. Okay, why we are using galvanometer to as an voltmeter, why we are using galvanometer to an ammeter? The reason is quite simple. Okay, because if I can measure only 1 milliampere current using galvanometer, if I am converted into an ammeter, I can measure up to 100 ampere. So the deflection, the full scale deflections, based on the full scale deflections, I can say up to 100 ampere, up to 1000 ampere I can measure. So for this kind of question, the deflection falls, the main current will be equal to 50. You can take it as 50. And the galvanometer current is equal to 20. Always the galvanometer current will be the lowest value and the total current will be the highest value. So total current will be equal to 50 deflections, 50 unit of current you can consider, and another one is 20 unit of current. So what will be the case of a shunt resistance? Shunt resistance means if you are connecting a low value of shunt resistance in parallel to the galvanometer, it will be converted as an ammeter. So question is not specifying as ammeter, but instead of giving a word called ammeter, question is stating you what is the shunt resistance I have to connect. You got it, huh? Two currents are given, 50 and 20. 50 is the main scale current. Instead of main scale current, a higher value is given. Higher value is a main scale current and lower value is the galvanometer current. So question is asking what is the shunt value connected. In which cases we will connect shunt resistor in case of ammeter. So question is indirectly asking you about ammeter. Okay. So what is the case of ammeter? We have a galvanometer. Parallel to galvanometer we have connected a shunt resistance will be here. Current through this one is Ig and the main current is I, and the current passing here is I minus Ig. 50 deflection, 20 deflection. You can consider like a 50 unit and 20 unit. Okay, so Ig, I minus Ig. That unit, so instead of deflections we will also call this parameter in case of galvanometric term, we will call it as figure of merit. So 50 figure of merit, 50 deflection, 50 unit, all thing you can consider as the same thing. So now we know parallel circuit voltages are same. So Ig into G is equal to I minus Ig into S. This already we know, we have learned from the galvanometer converted as an ammeter. So S will be equal to Ig into G whole divided by I minus Ig is equal to, what is the resistance of the galvanometer? Resistance of the galvanometer is given? No. Shunt value is given and we need to find out the resistance of the galvanometer. So all the values are available with us, we need to be substituted. So 12 ohm shunt is connected, so S will be equal to 12, galvanometer 20, galvanometer resistance we need to be find out G as per the question, I minus Ig, 50 minus 20 it is 30. So 0 0 cancel, 12 into 3. So we'll simplify these steps. So it become G is equal to 12 into 3 divided by 2. Correct? Then 12 into 3 divided by 2. So it becomes 6. 6 into 3 become 18. 18 ohm. Because S is given in ohm. So G is also in terms of ohm. 18 ohm is the right answer for 29th question. Answer is option A. Okay. This is a slightly different way of doing what we have done so far. Slightly different conversions method. Okay. A slightly different model of question, I can say. So question number 30, the next one, 30. When a long wire carrying a steady current is bent into a circular coil of 1 turn, the magnetic induction at the center of the coil is B. Now we have one wire which is bent in the form of 1 turn, and the magnetic moment at the center is equal to B. What is the magnetic moment formula? B is equal to mu 0 I divided by 2 times of R if R is the radius. This is what is given in the first statement. Second statement, when the same wire is carrying the same current and is in the bent in the form of a circular coil of n turns. So this is the same wire. Now it is bent in the form of a circular coil of n turns, like this, n turns. So what will be the magnetic field induction B dash? To find out this one, how many number of turns? N number of turns. So this is n turns. So the difference is like. Now we'll come to these equations. Okay, so general equation, so B dash will be equal to mu 0, it is same, then I, so I is the current for in 1 turn of the coil. If there are n turns will be there, it become Ni divided by 2 into R. R is not the original radius. Why? Because every circle will have a radius will be there. So instead you can consider like this is a 3-dimensional geometry. One circle here, and one circle, I mean it is like a spring. You can consider like it is a spring which is coming, which means one circle here, on top of this another circle, on top of this another circle, on top of this another circle, on top of this another circle. I cannot draw it in a 3D picture, like it is like a spring. You can assume like a spring. Spring how? First circle, same radius, second circle, same radius, next circle. So it is something like the second row. So one radius, the another. So all will have a radius of R. Okay, if you consider like a spring, bottom adhe circle next circle, adhe circle next circle, adhe circle next circle. So every circle will have a radius of what? R. So now I can say here total length will be equal to 2 pi R. But here total length will be equal to 2 pi R into how many R will be there? N times of R will be there. N times of R will be there. So instead of these R here instead of this R I can substitute L by 2 pi. I can substitute here. For example, mu 0 I divided by 2 into L by 2 pi I can substitute. L by 2 pi I can substitute. The same way here I am substituting L divided by, instead of R, what will come? 2 pi N will come. 2 pi N will come. Now if you do this one, what you will get? Mu 0. This N will go to numerator. So what you will get? N square times of mu 0 I whole divided by 2 into L by 2 pi. So what is this? N square times of what is this parameter? Mu 0 I 2 into L by 2 pi. What is this one? This is called a B. So it which become N square times of B. This is an important question. Normally for Neet and JE, these are frequently coming. The same, exactly the same model is coming. So remember this question statement. Or a long wire that is bent in the form of a single circle, and the magnetic field is called a B. Now the same wire you take and you make it as a spiral spring. So if this radius is R and this radius is not the same radius, it can be taken as R dash. So I'll put it as R dash, R dash, R dash, because this is a bigger circle. This is not a bigger circle, smaller circle. Okay. So this radius will be changes. So if it is bent in the form of a large number of circle, here this formula I can written as B dash will be equal to mu 0 I divided by 2r dash. I can put it like this, 2r dash. So from this one I'll derive to come to these steps. I become ni and r dash become L divided by 2 pi n, because this r dash and this r is not same, right? Earlier we have one wire with a bigger circle. Now we have the same wire but with the small circles. So the radius will be different. So r dash. So from this steps current become ni and r dash become L divided by 2 pi n will come. N number of r dash. I can say n number of r dash together will form r. N number of r dash is equal to r. N number of r dash. If r dash radius is 1 meter, if there are 10 circles will be there. So 10 into 1 is equal to 10 meter is the bigger circle radius. Hope you got right. Small ഒരേ വയർ 10 മീറ്റർ അല്ലെങ്കിൽ 2 മീറ്റർ ഇരിക്കുന്ന ഒരേ വയർ I can form a big circle, just one circle. With the same wire I need to form multiple circles with the same radius. It's like a spring. That's what it's doing here. And we got magnetic field induction for the n number of turns of the coil equal to n square times of B. So 30th answer is option D. Hope this is clear to you. We'll move to the next one. Fine. Understand and then learn, so that things are quite easy instead of by hearting the things. Okay, fine, perfect. Let's go to the next question, question number 31. Question number 31. The magnetic field due to a current carrying circular loop of radius r equal to 3 centimeter at a point on the axis, radius axis. So at a distance of x meter away, 4 centimeter from the center is. The magnetic field due to a current carrying circular loop of radius 3 centimeter at a point on the axis at a distance of 4 centimeter from the center is 54 microtesla, which means a radius of 3 centimeter at a distance of 4 centimeter away, the magnetic field will be equal to 54 microtesla. What will be the value at the center of the loop? So we need to find out what is the value. Here we have to remember the formula what we have learned in the previous classes. In the previous class, in the sense, in the theory sessions, what is the formula we have learned? So magnetic field at the, not at the center. At the center I know the formula. B is equal to mu 0 I divided by 2r. At a distance of x meter away, if this is taken as x meter away, then B is equal to mu 0 I r square into 2 times of r square plus a square whole power 3 by 2. R square plus x square, r square plus x square whole power 3 by 2. This is the formula we have learned from the class notebook. If you have not remembering the formula, please go back couple of steps back so that you can see this formula. 2 into r square plus x square. You can take it as r as x. Here I am considering r is the radius. We can consider again a also, any variable, but meaning should be the same. Okay. Now this is given to us. We need to find this, and this is given to us. That is a question. So let's do something and we'll see what we can do. So let me write this B is equal to mu 0 I r square divided by 2 into r square plus x square whole power 3 by 2. I need to get this formula from this one. So what should I have to do? I have to multiply it with r square plus x square whole power 3 by 2, so that both will get cancelled. Then what I have to divide extra? Here r square will be there, but I need a denominator with an r value. Okay, so the denominator r square plus x square whole power 3 by 2, it get cancels, but I need in numerator terms, in numerator I need 1 factors. So what should I will do? I have to divide with what? I have to divide with the, I need to get an r will be here, I have to divide with r cube. So now if you say mu square I r square and r cube will get cancels, 2r will come in the denominator, this will also get cancelled outside. But for s, this value is given in the question. What is this value? It is equal to 54 microtesla. 54 microtesla. Let me look into the option. Option is also in terms of microtesla. Okay. Let it be, will be that microtesla means 54 into 10 power of minus 6. Will substitute the value. R will be equal to what? 3 centimeter and 4 centimeter. So 3 into 10 power of minus 2 the whole square plus 4 into 10 power of minus, everything I am converted into SI unit for the standard way to do it. And r cube means radius cube. So 3 into 10 power of minus 2 the whole cube. We have to simplify this. We can simplify this, quite simple. 54 into 10 power of minus 6. Okay, 3 square is 9 into 10 power minus 4 plus 16 into 10 power of minus 4 whole power 3 by 2. And this whole divided by 3 square 9 into 10 power minus 6. Minus 2, minus 4, minus 6. Correct, minus 6. Next, we have to further simplify this. 54 and 9 will get cancels. 10 power minus 6, 10 power minus 6 cancel. 54 divided by 9 is 6. So, I know 6 into, here, 9 into 9 plus 16. Okay, 9 plus 16, I can say 25 into 10 power minus 4 whole power 3 by 2. First in the root, then we have to take it as a square. So first if you take the root, 6 into 5 into 10 power minus 2, that is the cube, which is equal to 6 into 5 into cube, 5 into 5, 25, 125, 125 into 10 power of minus 6 microwave. So 125 microtesla. 6 into 125 microtesla. That will becomes as an answers for this one. So 125 minus 2 minus 2, 3 by 2. So 124 Tesla. So how much will it, how much it should come? 125. It become 2 means 255. Okay. So let's multiply 6 into 5, 3. 6 into 12, 6 into 2, 12, 12 plus 15, balance 1, 750 microtesla, 750 microtesla. It's not there in the option, right? 750 microtesla. Let me revisit this one, whether I got any mistakes over here. Mu 0 I divided by 2r is the magnetic field induction at the center of the coil. Mu 0 I r square into 2 into r square plus x square whole power 3 by 2. Now we have substituted x square plus a square whole power 3 by 2. It become, I converted everything to SI system. There are no differences to this one. So question is giving like 54 microtesla. So 54 into 10 power minus 6. R is 3 into 10 power minus 2. 4 into 10 power minus 2 ohm. Okay, then whole power 3 by 2 divided by cube. So 3 square 9, 10 power minus 4, 4 into square 16, 10 power minus 4 whole divided by 3. Oh, here there is a mistake, right? Here I have to take 3 cube. I have to take, instead of this one I have taken 3 square. So there is a mistake I have made. I have to correct it. Okay, so sorry for that. These steps, right? Here 3 square 9 is not 3 square, 3 cube. 3 cube we have to write it. So 3 cube is 27. Sorry for that. 27 into 10 power minus 6. So this will get cancelled. Now it become 2 and this will get cancels. So 2 into within bracket 9 plus 25. 25 into 10 power of minus 4 whole power 3 by 2. So in the first root, then we will take the cube. So 2 into 5 into 10 power minus 2 the whole cube. Root cube. So 5 into cube is 125. 125 into 2. 250 into 10 power of minus 6, which is equal to 250 micro Tesla. 250 micro Tesla. So 31 answer is option C. Now I got it. So here is the mistakes I have done. I corrected it. I got 25 micro Tesla is the right answer for question number 31. Let's move to the next question. Question number 32. Okay, you can pause the video. I am not as like the real physical offline classes. I am not giving the time to write it from the board, because here the big advantage is like time saving. You can pause the video and you can complete the notebook, because I can go one after another questions without waiting for you to be right. Okay, so let's move question number 32. A charge moving with a velocity v in x direction subjected to a field of magnetic induction in negative x direction. So a charge is moving with a velocity. A charge means I'll take as, if question is giving a charge means we'll take as plus q always, unless otherwise it's not specified as negative q or electron. Electron minus q. So charge, if the plain spoken like charge, we can take it as plus q in positive x direction, and a magnetic field will be there in the negative x direction. As a result, the charge will F is equal to q into v cross b. Q is a charge, velocity in x direction, so it becomes vb sine theta. Velocity, the charge is moving with the velocity b and magnetic field is in this direction, both are in opposite direction. So qvb of sine of 180 degree. The reason is v and b are in opposite direction. Opposite of the angle, how much? Angle is 180 degree. Are in opposite direction. If they are in opposite direction, sine 180, there is no force. There is no force because of the magnetic field. The charge is unaffected. Charges will still move because the magnetic field has no effect on the charge, which means no force is not actually acting on the charge. So it will be remains unaffected. So 32A, it will be remains unaffected. We'll move to 33. 33. An electron traveling with a speed u along the positive x-axis. So an electron is moving, so I can say minus q, charge is moving in this direction. U with a speed u along the positive x-axis enters in a region of magnetic field where b is equal to minus b0k. You can see in this diagram they have marked as like this, so which means into the board. B is equal to b0 times of minus k. Minus k means into the board, is a minus is a axis, plus k means out of the board. Okay, so next into the board. Now what we will do this one here, you know, we will apply the formula. F will be equal to q into v cross b. Okay, so q is minus q, of course. Velocity is in x direction, so it is vi cross b. B is in what direction? B is in into the board, so b0 times of minus k. So what will you get? I cross minus k, we know I j k. I cross k is what? Minus j. I cross k, reverse with minus j. Okay, so let me put it as this minus and this minus become plus. Okay, this minus and this minus become already plus. What is that? Then what is balance? This minus is taken here, so this minus and minus become plus. What is balance? I cross k. What is I cross k? I cross k means vb of minus j will come. I cross k is vb of minus j. Vb of minus j. So vb of minus j means if I am doing v cross I means I cross k. Here the velocity is in this direction and magnetic fields are into the board, both are perpendicular, so VB sine 90 will come, sine 90 degree. Here we got sine 180, here we got sine 90. Because electron is moving like this, magnetic fields are into the board, both are 90 degree. So this is the value of force. So force F will be equal to QVB minus J. Minus J means what? Force direction is minus J. If force direction is minus J means minus Y axis. The electron will come here and will move like this. Will move like this. Initially it is coming with a speed of u. I told while I am taking the theory, when an electron enters into a perpendicular magnetic field, it will undergo circular motions with constant speed. So initial speed is equal to final speed. Both are same. With all this understanding, the answer to the question is 33, answer B. V is equal to u and y is less than 0 because it's moving to the negative y direction. That is the meaning of this one. So 33, answer is option B. Okay, hope this is clear to you and you got some clear info from this. Okay, so let's move to the next problem. Perfectly fine so far, I hope so. 33. Good. Okay. So let's move to the next question, question number 34. Question number 34. We are approaching the end. 34. If an ammeter is to be used in place of an voltmeter, then we must connect with an ammeter. If an ammeter is to be used in place of voltmeter, already voltmeter will be there. Now we used an ammeter. So then we must connect ammeter with a high value of series resistance. Then only it can be converted into voltmeter. Read the question, confusing statement. If an ammeter to be used in place of voltmeter. So what is actually there? Voltmeter will be there. What is actually there? Voltmeter will be there. I have an ammeter. I need to convert ammeter into a voltmeter. What should I have to do? To convert into a voltmeter, we have to connect a high value of series resistance. So by that understanding, answer to the question is 34C. We'll move to the next question, 35. An infinite long straight current conductor carrying a current 2I split into the loop of radius R as shown in the figure. The magnetic field at the center of the coil will be. Okay. This is a good question. Look like. So 2I current is coming. Magnetic field at the center. So 2I current is split as I and I. This is an interesting question. See. So the magnetic field along the line will be equal to. So here magnetic field due to first conductor, the upper portion, second half, lower half, then 4 pieces will be there. So magnetic field due to 1 is equal to 0 because it is along the axis. Along the axis. This axis is magnetic field. Similarly, B4 equal to 0. Next, B2 equal to magnetic field due to a half circle. Half circle means what? Full circle is 2R. So mu 0 I divided by 4R. But direction is important. See. If you are using your right hand, thumb rule to find out the direction of magnetic field, thumb is giving the direction of current and magnetic fields are into the board on bottom and top it is coming out like this. If you are using your right hand here, it's like this. So here it is into the board. Here it is into the board. Okay. So into the board, how we are normally representing with a cross signs. Okay. Next, magnetic field at the lower half, B3. B3 is also an half circle, mu 0 I divided by 4R. But how the magnetic fields will be here? I am using my right hand, bottom side into the board and here it is out of the board. So here it is out of the board. So total magnetic field B is equal to B1 plus B2 plus B3 plus B4. B1 0, B2 is into the field and B3 is out. Both are magnitude wise same, mu 0 I by 4I. B1 magnetic field along the axis 0, B2 is a magnetic field into the board, B3 is the magnetic field out of the board. Both are equal magnitude but in opposite direction, into the board, out of the board, both will cancel, it becomes 0. Then finally B4 is also equal to 0 because it is along the axis. So all are 0. Answer to the question is also 0. This is an interesting kind of question. The same model of questions may come for the upcoming Neet and JEE examination. So 35 answer is option D. Let's move to the next session, next one. 26, not 26, 36. Okay, let's have a look into the question. A parallel plate capacitor of area 60 centimeter square and a separation is 3 millimeter is charged initially to a 10 microcoulomb. Capacitor is charged. Capacitor area is also given. If the medium between the plates gets slightly conducting, it's a conducting medium we can say, and the plate loses the charge initially at the rate of 2.5 into 10 power minus 8 coulomb per second. Means in 1 second 2.5 into 10 power minus 8 amount of charge is losing because of the conduction property between the plates. Then what is a magnetic field between the plates? So if it is a pure conducting medium, between the plates of a parallel plate capacitor there are no magnetic field exist. It's a straightforward theory. So answer is D, magnetic field is equal to 0. 37th. 4 wires each of length 2 meter are bent in the form of a 4 loops P, Q, R, S suspended in a uniform magnetic field. If the same current is passed, then torque will be maximum on. So torque will be equal to, I know M cross B, which is equal to MB sin theta. M is equal to NIA B sin theta. So torque will be depends upon the area vector. Okay. So by mathematical principle or by maths, any shape it is given. First one, if you see P is a square, Q is a rectangle, R is also a rectangle, S is a circle. So the circle will have the maximum area comparable to all the geometrical shape. So circle will have the maximum area means circle, torque for circle is maximum. That's a basic principle. So if you have a wire, you bend in the form of a square, you measure the area. If you have a wire, you bend in the form of a rectangle, you measure the area. If you have a wire, you bend in the form of a circle, you measure the area. So circle will have the total area. By comparing all the structures, circle will have the maximum area. That is a basic mathematical principles that you have learned in geometry. Okay, so answer is D. S will be the answer. Circle will have the maximum area, so maximum torque will be there. So 37 answer D. 38. 38. A certain region has a magnetic field, has an electric field is given 2I minus 3J Newton per coulomb, and a uniform magnetic field B 5I plus 3J plus 4K Tesla. Force experienced by a charge 1 coulomb moving with a velocity V is given by. Okay. So what we have to find out, electric field will be there and magnetic field will be there. We need to find out the force experienced by. So what is the force? That force is called the Lorentz force. So we need some space to solve this one. So I have to clear the board. Okay, so let's look into the question. Electric field is given, magnetic field is given, a charge of 1 coulomb is moving with a certain velocity is also given. So the charge is exposed to what are the things? Exposed to both electric field and magnetic field. If both electric field and magnetic fields are existed, then a force which is existed, there it is called the Lorentz force. So FL equal to, actually we are going to find out Lorentz force Q into vector E plus V cross B. This is what we are going to find out. Okay, so first I am interested to find out V cross B, because V is given as how much? I plus 2j, and B is given as 5I plus 3j plus 4k. 3j plus 4k. So I will do V cross B first. I have to simplify, nothing else. So I, j, k. V in the first. So V in the 1, j in the coefficient 2, k in the coefficient 0, B in the 5, 3, 4. You can solve along with me. You don't want to wait it for me. Then we'll say you are getting the same answer. We are both are getting the same answer. So I rho get cancels. So 2 into 4, 8. 8 minus, how will multiply? Like this, right? So 2 into 4, 8. 8 minus 0. So second one is minus. First one is plus. Second one is minus. So this will get this column. So if you take j means this column, and this row you forget about it. Then how will multiply this 1 with this 4? 1 into 4. 4. 5 into 0. 0. That's all. So once it is done means it is done. Okay. So this is over. And the last one is what? Last one what we are doing for k. So first one is plus, second one is minus, third one is k plus k. Okay. Plus k means this column and k included in the rowing column cancelling. So 1 into 3 and 5 into 2. 1 into 3 is 3. 5 into 2 is 10. Minus 3 minus first minus second. That's all. So it become 8i. It become 4j. It become minus 7k. So I got this one. Now I have to substitute all the values. So the Lorentz force equal to, charge is 1 coulomb, so I don't want to bother about it. And electric field is given. What is the value of electric field? 2i minus 3j. So 2i minus 3j. 2i minus 3j and plus V cross B, 8i minus 4j minus 7k. So 2i 8i 10i minus 3j minus 7j minus 7j minus 7k. So this is what I got. Let me see whether I have the answers will be here. 10i minus 7j minus 7k. So answer is option A. Option A. This is what's the number? 38. 38. Answer is option A. Simplified, we got the answers. So direct formula. Okay, there is a chance it's not so very easy to get it, but there is a chance to ask this model of questions to you. Okay, fine. Let's move to the next question, 39th. Fine. This is a straightforward question, right? Based on the Lorentz force, if you know the equations, we can substitute. Nothing complex will be there. So let's move to the question number 39. A galvanometer of resistance Rg is given as 100 ohm. Galvanometer resistance is 100 ohm. It's given. Gives a full scale deflection current of. Full scale deflection current means galvanometer current is always lesser, I told, right? To convert it into an ammeter capable of measuring 1 ampere. So that's the main current is highest value. What should be the resistance? Should be connected. I know we have galvanometer. We have a shunt resistance. Both are connected. This is main current. This is a galvanometer current. This I minus Ig is coming. This is a shunt resistance. So I know I minus Ig into shunt resistance is equal to Ig into galvanometer. So shunt resistance has to be calculated. So S will be equal to Ig into G divided by I minus Ig. What is Ig? Galvanometer 10 power minus 5. Galvanometer resistance is 100 divided by I minus Ig. I minus Ig. So the main current 1 ampere which needs to be subtracted from, what is the value of this, the other value, 1 minus 10 power minus 5. 1 minus 10 power minus 5 is nothing, it's negligibly 0. So what should be the value we are getting? 1 minus, so if you see this become 10 power minus 3 divided by 1 minus 0.00001. So this is negligible, nothing will be there. So this can be written as 10 power minus 3 divided by almost 1 itself. So this much ohm needs to be the resistance which needs to be connected in parallel with the system, so that this system will be behaving as an ammeter. So 10 power minus 3 ohm resistance needs to be connected in parallel. That is another option B. So 39th option B is the right answer. Let's move to the next question. Question number 40. 40. What is the 40 question is speaking about? A square loop which is carrying a current, steady current, is placed in an horizontal plane near a long straight conductor carrying a steady current I1 at a distance d from the conductor as shown in the figure. The loop will experiences. Okay, let's draw the first one. So this is a conductor which is carrying say current of I1. And we have a square loop will be here, and this is carrying a current of I like this. Okay, so because of this conductor there are forces will be here. So if two conductors are carrying current in the same direction, there is an attractive force F1. If two conductors are carrying current in the opposite direction, the first one and the last one, it is a repulsive force away from this one, F2 I am marking. And these two conductors are at same distance, and these are carrying the same force F and F. So these F and F will be cancelled. But here what is the total force? Here it is an attractive force. Between this and this is what? Repulsive force. Repulsive force. What is the force equation? Force per unit length will be equal to mu 0 I1 I2 divided by 2 pi d. Force per length, the force equal to L will be here. Now there is an attractive force, there is a repulsive force, but for attractive force and for repulsive force, I1 and I2 will be the same because these are the current, that is constant. But what is changing? Distance is changing. Distance is changing. So if you substituted this formula for attractive force, the distance is only this much, d distance will come. But if the square plate will have a length of A, then I can say F1 will be equal to the first force mu 0 F1 I1 I2 into L divided by 2 pi d will come. But F2 is what? Mu 0 I1 I2 into L divided by 2 pi into d plus A will come. The distance are increased. So this is what kind of force? This is an attractive force. This is what? A repulsive force. Parallel conductors only you need to consider the perpendicular conductor, the magnetic fields are getting cancelling each other because it's the same distance away from this one. This already we have discussed, right? So this is a perpendicular conductor. You can forget about perpendicular conductor. So the force experienced by this conductor, force experienced by these conductors are equal and opposite, and it will cancel each other. You only bother about the parallel conductor. This is one parallel combination, and this with the last one is also a parallel combination. So the first one will give an attractive force because currents are in the same direction, but this wire and this with the last one, currents are in opposite direction. So it is a repulsive force. So here attractive force is higher or repulsive force is higher. Denominator is lesser for attractive force. Denominator is more for repulsive force. So I can say F1 is greater than F2. So there is a, this coil will attract towards the above wire. So it's a net attractive force towards the conductor. So 40th, Question answer D. 40th question answer is D. There is a net attractive force will be here. These two forces cancel. This is an attractive force, this is a repulsive force. Attractive force is higher because distance is shorter. So net force is attractive in nature. Fine. We'll move to the next question. Question number 41. Two coaxial solenoid of different radius are carrying a current I in the same direction. F1 is a magnetic force on the inner solenoid due to the outer one, and F2 will be the magnetic force on the outer solenoid due to the inner one, vice versa, like that. Okay, so two coaxial solenoid means one axis le rendu solenoid. One solenoid is smaller one, another one is bigger one. So the smaller solenoid will give F1 will be the magnetic force on the inner solenoid due to the outer one, and F2 will be the magnetic force on the outer solenoid due to the inner one. Then answer is quite simple will be here. Answer is option C. F1 equal to F2 is equal to 0 because reason is action and reaction. Action and reaction pair cancel when they are acting on each bodies. Okay, action and reactions pairs are cancels when they are acting in equal and opposite directions, in equal and opposite direction. Action and reactions pairs cancels when they are acting equal and opposite direction, which means inner one solenoid, outer bigger one. So inner solenoid will act a force on the outer solenoid, outer solenoid will act a force on inner solenoid. Both forces are equal and opposite and it will cancel each other. These are acting on different bodies, of course. One is acting on outer body, another one is acting on inner body, but the line of action, line of action means at what line these forces are acting, that is on the same line. So in that line of action, the forces are, one is up, another one is down. That's what it is getting, cancelling each other. Okay, fine. Let's move to the next question, 42. 42. A beam of electron is moving with a constant velocity in a region having simultaneous perpendicular electric and magnetic fields. Strength will be there. So electric field E is given as 20 and magnetic field is given as 0.5 Tesla. So 0.5. All are SI unit, volt meter raised to -1, and this is Tesla. Both are right angles to each other in the motion. Then the velocity of electron, velocity will be equal to E by B. E is 20 divided by 0.5, which is equal to 40 meter per second. Velocity is equal to electric. From where we have learned this concept? We have learned this concept from cyclotron. Cyclotron. Straightforward question. 42, answer is C. Let's move to the next question, 43. Magnetic flux density B at a distance R from a straight wire carrying a steady current. Okay, so this is a wire which is carrying a current of R and this distance is R. So the magnetic field will be here equal to mu 0 I divided by 2 pi R. 2 pi R. Don't confuse. For a circle, the magnetic field at the center with a radius R will be is equal to B equal to mu 0 I divided by mu 0 I divided by 2R. Circle is 2R. Here it is 2 pi R. R is the distance. So if you are plotting the graph for the magnetic field inductions with the distance R, it is decreasing, but it's not a straight line because mu 0 affect 2 pi effect. Because of this one, this is like a slanting graph, a slightly a parabolic graph. Okay, it's not like a straight line graph, it's a parabolic graph. So 43, answer is option C. 44. AC voltage across a resistance can be measured using moving coil galvanometer. AC voltage ആയിരുന്നാലും it can be measured using moving coil galvanometer. Moving coil galvanometer can be converted into a voltmeter and we can measure the voltage. So 44 answer is B. 45. When a charged particle is moving with a velocity v subjected to a magnetic field of induction B, force on it is non-zero. This implies F will be equal to Q into V cross P. So if a charged particle is entering to a magnetic field without an electric field, this is the formula for magnetic force. So this magnetic force F is equal to QVB, F is equal to QVB sin theta. It is given this force is not equal to 0. At what condition? Let's have a look. Angle between V and B necessarily 0. It should be mandatorily 90. Once it become 90, it is not 0. But it can be become 30 also, right? Sin 30 is 1 by 2. So it is not necessarily 90. It can be 30, 40, 45, other values also possible. Angle between V and B can have any value other than 90 degree. No, other than any value other than 90 degrees not possible. Any value means 0. Sin 0 if you take 0. Sin 180 if you take, force will be equal to 0. So that is wrong statement. Third one, angle between V and B can have any value other than 0 and 180 degree. That's the right statement. So other than, so I can say other than 0 degree and 180 degree, F not equal to 0. F is not equal to 0. Angle between V and B either 0 or 180 degree. No, if fourth option I am saying, if it is 0 and 180 degree, force will be equal to 0 degree. Out of the given option, what will be the most appropriate answer? Appropriate answer is option C. So 45, answer to the question is option C. So I done my work. You have to do your work. Okay. That's the next stage. So magnetic moving charges magnetism chapter is over. Classroom discussion question is over. So please do it, because I know like all the faculties are doing the question discussions in a very well way. So make use of the opportunity and learn this theory. So what you have to do next? Okay, as like I'm told, always first learn the class notebook theory either 2 to 3 times, then do the classroom discussion question paper. While taking the theory itself, I have solved lot of questions will be there. So please solve that questions along with the theory. Then do this classroom discussion question paper. The next is 2 stage, 15 years of Neet previous year question paper, you have to work it out. 15 years of JE main paper question paper, you have to work it out. Then whatever the examinations are conducting here, whether it's a daily test, section test, part test, model test, whatever, so you are going to write, it will be here. All the test question papers, definitely you will get a new questions and unknown questions will be there. So you have to learn this. So this is the only thing you have to do, and try to read it NCERT textbook also if possible. Not the theory, at least theory if you are reading, it's well and good, but at least try to do. There are a lot of objective questions will be there between the chapters, and at the end of chapter there are subjective and objective questions will be there. At least try to practice objective questions if you are going to write an objective examinations. Okay, so I recommend all these things to do to get a good score. So all the best, and we will see with a new chapter in the next class.